Hey guys, Arthur here. I'm a math major. Today, I'd like to talk to you about sets. In the large majority of pure math textbooks, if you look at the index, of course, there's going to be many chapters, but most of the time, the first chapter is going to be dedicated to set theory. Okay, and that's just because sets are super useful. Okay, they're the building blocks of pure mathematics. It's the very first thing you need to learn before you start to learn pure math, and they're even really important in applied math as well. But what are they? They're essentially a collection of objects. Okay? And the objects are called elements. This is a jar of marbles. Okay? The marbles represent the elements, and the jar represents the set. Another example of a set could be a parking lot filled with cars, right? The cars represent the elements, and the parking lot represents the set. The numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then so on forever, those also represent a set. They're called the natural numbers. And if you would look at a math textbook, the way you would recognize this set is with the letter N. This letter N with a vertical line to the left. Now here I've drawn another example of a set. This is a really simple set. Now there's a lot of new things here, so just bear with me. The capital A represents the set. Okay, and that's how we usually represent sets in math. Okay, we usually denote them as capital letters A, B, C, D, whatever. And then the 1, 2, and 3, those are the elements of the set. So the set has 3 elements. And what about these squiggly parentheses? Well, that's just to indicate a beginning and an end to our list of elements, right? So here we begin with our first element, so we add parentheses onto the left of it. Now we start listing our elements, and once we're done listing all of our elements, we put another parentheses here. There's also the concept of cardinality. So the cardinality is just how many elements are inside of a set. So yeah, there's 3 elements in our set, so we would say that the cardinality of A is 3. Of n, or the set of all natural numbers, right? We said that was 1, 2, 3, 4, 5, and so on forever. How many elements are inside that set? Well, I think the word that I said just a moment ago, forever, pretty much gives it away. Yeah, it's infinity. That gives us a very important characteristic of sets. Some of them are finite, and some of them are infinite. So, something important to keep in mind. Now, notice here I've drawn 2 sets, A and B. A contains the elements 1, 2, 3, and 4, whilst B contains the elements 1 and 2. What you may notice here is that all of the elements of B are inside of A. This leads us to another definition known as a subset. Okay, a subset is a set within a set, essentially. And this is the case with B, if A and B here. We see that B is already in A. So another way that we could write A is like this. That means that we can count a set as an element of a set. There is such a thing as a set made up of sets, a set whose elements are sets, and yeah, it gets pretty big. If you see this symbol in a math textbook, you know that it means that the set B is contained within the set A. So those are just the very basics of sets. If you like this, please make sure to leave a like, subscribe, and stay curious.